In this short video, I will show how to set up the tinyGTC to measure the jitter of a GPS PPS. Whenever we want to measure a pulse from a pulse output, like for instance a PPS signal from a GPS receiver, and we don't know exactly the output voltage of that PPS output, we have to be extra careful. One good way to protect the tinyGTC is to use a 20 dB attenuator between the PPS output of the GPS receiver and the tinyGTC. In this case, I've inserted this 20 dB attenuator between a GPS receiver and the tinyGTC input. And because the input volt, the trigger level is set to 3 volt, at this moment we don't see anything. So now I can stepwise reduce the trigger level and see at what trigger level something starts to happen. Let's first go to 1 volt in case the output of the PPS is 20 volt peak, and we still don't see anything happening, so the output voltage must be lower. So maybe it's a digital voltage in the range of 3 or 5 volt peak. So we set the trigger level to 0.1 volt and we see the triggering happening and we see the input frequency. Now we could remove the 20 dB attenuator and set the trigger level to 1 volt, but for many measurements that's not needed. The sensitivity is good enough to go with the trigger level of 0.1 volt. Let's go a bit higher to see if we can see the maximum input level, 0.2. So there's no triggering anymore. Let's go for 1.5, 0.15. So the input is probably in the order of 1 volt. If it's 1 volt, then we should have a trigger at about half the level. So we go for 0.05. And now we know that we are roughly in the middle of the pulse, so we have we can expect a stable trigger. Now the next step is to prepare the counter for the measurement of the jitter of the input. And to do that, the first thing we do is we look at the gate time. The gate time is currently set to 1 second, and that may not be optimal because in this case the pulse from the PPS output could arrive before the gate is being closed. So what we do is we set the gate time to 0.9 seconds, so we're sure the received pulse from the PPS output will cause a triggering and will cause a closing of the gate. So now if we set up the counter correctly, we can look at the jitter. We can see here the jitter in the frequency, but the jitter in the frequency is always a bit difficult because that is influenced by the current and the previous pulse. So it would be much nicer if we could see the timing of each individual pulse. One of the options to make the jitter visible is to look at the timestamp. We go into the measurement menu and we click on timestamp. And what we should see now is a continuously increasing number, and that's because that's the amount of seconds since the start of the day that the time pulse arrives. As this is difficult to see, you could of course go for a transform like lin-res, or you could go for the measurement of the timestamp, and you could say, well, let's do a time wrap of 1 second, because that will remove the offset in the increasing number, and it will show you the jitter of the pulse against the time in the tinyGTC. But there's also another option, and which may be easier to use, and that's as a measurement you select the phase. And you select phase against an NCO, so against NCO should be enabled, and then as NCO frequency you set 1 Hz. And now this will take care of all things needed to see the jitter. And here you see the jitter. The vertical scale is 17.5 nanoseconds, and that's about correct for this GPS module. So this is a very simple way to visualize the jitter of a PPS output of a GPS receiver.